Okay, so the next section of our transformation unit is dilations. So we've talked about three kinds of transformations so far. We've talked about transformations, translations, which are slides, rotations, which are turns, and reflections, which are flips. All of those, when they're performed, create a congruent polygon, meaning everything is the same size, same shape, angles are the same, nothing changes. When we talk about a dilation, we actually change the shape because we're going to make it either larger or smaller. So if you think about the pupil in your eye, the black part of your eye, when you're in a lot of light, that pupil is really small because your eye doesn't have to work to bring in light. But then when you go to a dimmer light or even in the dark, that pupil gets really large because it's trying to draw in as much light as it can. So that's really what a dilation is. It's an object getting larger or smaller, and we do that by multiplying the coordinates to see what that does. So lesson 6.2.1 in our CPM book, if you want to look at that, you sure can. The problems we focused on in class were 6-42 and 6-43. I thought those were the ones that gave us the most information that we would need. So the first one, 642, they give us some coordinates, and then they want us to make a quadrilateral out of those coordinates, and so that ends up looking like this. So we have this quadrilateral that looks like this before we dilate it. So this would be our pre-image. And then they want us to make a prediction about, well, what would happen if we multiply all of the coordinates for this polygon by 2? So the kids made some predictions. Some said it would get bigger. And then we actually went ahead and we did that. And so I'm going to go ahead and do that now. I'm going to move this down a little bit. We're going to need a little bit more screen here. So now I'm going to multiply each of these. So that means this coordinate of 2, 1, the new coordinate would now be 4, 2. So I'm going to go ahead and plot that one here. And disregard this point here. I was thinking about doing something else. Our next point of B, which was 3, 1, now becomes 6, 2. So I'm going to plot that one here. The next point of 5, 5 right here becomes 10, 10. So 10, we didn't go far enough. Hold up. Okay. And you can do all of this in the GeoGebra app. That's what I'm using. And then the last coordinate right here of 5 or 2, 5 ends up being 4, 10. So 4 and 10, that's our last one. We're going to go ahead and make those a polygon so we can see what happens. So this is what happens when we multiplied all of these coordinates by 2. Not only did it get larger, it also translated. So usually what happens with a dilation is there's a series of transformations that take place. You can also notice that our angles did not change. I still have a right angle here. I have an obtuse angle here. If I would slide this polygon over the top of that one to check, I can do that right now. So if I would check my angles here by just sliding, I would see that all my angles stayed the same. But I also noticed that my side length from here is also, it's twice the length. Okay, so I would notice I only have 4 units here, but this side is now 8 units. So that's twice the length. So I changed the size of the polygon, but I did not change its angles. So then we would call them similar figures because they are the same shape. Their shape did not change, their angles did not change, but their side length did. So that's really what we talked about for 6-42. The next problem that we talked about in your book, ebook, would be 6-43. And that one is the students in Miss Stanley's class were studying what happens to the graph of a shape when both coordinates are multiplied by the same number. They came up with these questions. What happens when we multiply when each coordinate is multiplied by 1/2? What happens when each coordinate is multiplied by 1? What happens when each coordinate is multiplied by a -1? And what happens when each coordinate is multiplied by 2? Or -2, my bad. So I went ahead and I have graphed my original shape. This is my pre-image. So this was the image that the kids were asked to work with. Then they had to go through and they took the coordinates that were given and figured out what coordinates would they need for if they multiplied by 1/2. So I'm going to see if I can get rid of that point there. There we go. We don't need that point. So if I multiply each of these coordinates by 1/2, well, what do you think might happen to the shape? So if I multiply this coordinate here of -6, 8, well, I'm going to ask myself, I can either multiply 1/2 times a -6, that gives me -6/2, or I can just say to myself, well, what is half of a -6? Well, that's -3. Well, what's half of 8? That's 4. So I know that my new coordinate is going to be -3, 4. So I'm going to plot that one. It's a little bit different just because my graph is a little bit different. My B coordinate now becomes -1, -2. And my C coordinate now becomes 3, -2. And then I'm going to make those a polygon. So then we can look at what happens to the shape when we multiply by 1/2. Well, we got smaller. Our angles, did they stay the same? So that's something that we could look at. So I could drag my shape. Yep, that angle stayed the same. That angle stayed the same. And that angle stayed the same. So yes, my angles did stay the same. I don't know if I'm going to get that exactly in the right. There we go. So again, we have a similar polygon, but not a congruent polygon. The next question is what happens when each coordinate is multiplied by 1? So, well, that's pretty simple to answer because if I multiply -6, 8 times 1, I'm still going to get -6, 8. So when we multiply by 1, our figure stays exactly the same. We do get a congruent figure or a congruent polygon. The next question says, well, what happens when each coordinate is multiplied by a -1? So basically, I'm going to change each sign to its opposite. So I'm going to graph that for you here. Well, I'm going to move this a little bit because I'm going to need to have more space. So now, instead of A being -6, 8, it becomes 6, -8. So 6, -8. So this is now my A point, which is going to be G in this case. My B, instead of being -2, -4, becomes 2, 4. And C becomes, instead of becoming 6, -4, becomes -6, +4. So if we observe what happens to the shape when we multiply the coordinates by a -1, it simply becomes inverted, basically. Or what I also told the kids and I in class looked at this. Well, when we rotated the original shape around the origin, it was actually a 180-degree turn. So we looked at it being a reflection. It was not a reflection because that flipped it, but it did turn 180 degrees. So that's what happens to that. And then we can look at, well, did we change angles? No, because if it's a rotation and we're ending up with the same thing, this also gives us a congruent polygon. So now we know when we multiply coordinates by 1 and -1, we still get a congruent polygon. Now let's look at what happens when we multiply by a -2. So when I multiply the original coordinates by -2, I get a -12 and a +16. So clearly I'm going to have to make my graph, they're smaller maybe. So -12, 16 is our first coordinate for that. And then B, which was -2, -4, if I multiply it by a -2, I get -4, -8. So B here. And then C becomes 12, -8. So I'm going to make those a polygon. Oh, I didn't multiply by negative, I multiplied by positive. But essentially, this is what it would look like. If we multiplied it by a negative, it would be inverted like this one. But as you can see, it's twice as big as our original polygon. So all those things happened. So I had the kids reflect on, well, what happens, what relationships did you notice through all of those different dilations? Well, when I multiplied by a half, my image got smaller. So, and my side links got shorter, but my angles remained the same. When I multiplied by 1, everything stayed the same, even the position. When I multiplied by a -1, my image was inverted or turned 180 degrees, but everything else, the polygon stays congruent. Nothing, side links, angles, all those things remain the same. When I multiplied by 2, my image then became twice as big as my pre-image, so my side links increased to be twice as long. However, my angles remain the same, so I still have a similar figure, but it's not congruent. So this kind of sums up what we do just to begin dilations. So I'm going to give you some practice problems today to work on as well. And there's also another video included in your slideshow if you're having difficulty with those problems.